All right, guys, this is going to be the graphing review, the trig graphing review video. The reason I'm using the key instead of actually going through and doing it for you is that this pen doesn't really work very well. It doesn't draw very straight lines. So it's a lot easier for me to just walk you through it rather than draw it, because you won't be able to understand what I'm drawing because it doesn't draw very well. So anyway, so we're looking at 2 cosine x minus pi minus 1. All right. Well, the first thing I would look at is, well, where does cosine normally start, right? Cosine starts at 0, 1. That's where cosine starts. So if I have a phase shift of pi to the right, because it's the opposite of this, so to the right pi, and then I have a negative vertical shift of 1. I have vertical shift down 1. So my point's going to be right here. But we've got to remember that we shifted the entire graph down. So we shifted the entire graph. So originally on my graph, my point was here, and my midline was here. And then I had another point down here. My graph went from 1 to negative 1. Well, if my top point right here shifted down to here, now my cosine graph goes from 0 to negative 2, right? With this being my midline, all right? Well, if that's my midpoint between my peaks and my valleys, well, now I look here and I say I have a vertical stretch of 2, all right? Well, right now, where I put my spot was right here. That's only a stretch of 1, so that's why it needs to bump back up to 1, to pi 1, and that would be my first point, all right? Well, now I know that I have a stretch of 2, so each time I move an interval, I'm going to go either up or down 2. So I know my period is 2 pi, because nothing has changed over here as far as period goes. And I know my interval is pi over 2, because it's just the period divided by 4. So if I have my point here, if I move over pi over 2, I would go down 2. All right? And then I'd have a point there. I would go over pi over 2 and down 2. And that would be my point. All right? So then if I come back up here and I go over pi over 2 this way, I would go down 2. All right? This thing is awful. I would go down 2. And then I would go over pi over 2 and back down 2. And then this would just continually repeat to form my new cosine graph. All right? My domain is negative infinity to infinity, because this can continue on forever. And my range, now, my possible y values go from negative 3 to positive 1. That's why it's including negative 3 and positive 1. We have a vertical stretch of 2. That's what this number represents, vertical stretch of 2. And we have a vertical shift of negative 1. We shifted the entire graph down 1. All right. We also had a phase shift of pi, so we moved it over pi. All right. So now let's take a look at the next graph. So the next graph says sine of 2x plus pi over 2. All right. Well, we know right away that the normal period for sine is 2 pi, but I have this 2 right here. I have that 2 right there, and that means that I need to take my normal period of 2 pi and divide it by that number to get my period for this graph. So I would take 2 pi divided by 2 and get my new period to be pi. Well, now to find my interval for this graph, I take my period that I figured out and I divide it by 4. So my intervals are going to be pi over 4. All right? We also have a phase shift. We have a negative phase shift of pi over 2. So normally the sine graph starts right here at 0, 0 and goes up to the right. Well, now I need to shift it back pi over 2. That's why my starting point is going to be right there. All All right? We haven't changed anything vertically. We haven't shifted anything vertically. We haven't stretched anything vertically. We don't have any of those in this graph. So now I would just simply move over an interval from my starting point, which is I need to move over, my intervals are pi over 4. So I go over pi over 4, and I go up 1. Well, then I go over pi over 4, and I go back down to my starting point. Over another pi over 4, and down 1. Over pi over 4, and back up 1. And this is just repeating the wave of the sine graph. All right? And then we continue that on. And that's why the domain would be negative infinity to infinity. The range would be negative 1 to 1, because that's the possible y values in here. We did not have a vertical stretch. We did not have a vertical shift. Our phase shift was negative pi over 2. It was pi over 2 in the negative direction. And our period came out to be pi, and our intervals were pi over 4. All right? So now, once I get the pen working, let's shift over to the next graph. All right, the next graph is 2 cotangent of x plus pi over 2. All right? Well, my cotangent graph normally starts at pi over 2, right? Well, now I have a phase shift of negative pi over 2, so that would mean that it would start now back at 0, right? So if I'm back at 0, then, and I know that, okay, I have the only other thing I have on here is a vertical stretch of 2. That means my period stays the same for cotangent. My period always starts as pi for cotangent. That means my intervals are pi over 4. All right? So if I have my starting point, then I would just simply go over pi over 4 one way and to the left, and then I would go up 2, right? Because instead of going up 1, I would go up 2 as my for my vertical stretch. And or I could go over 1 this way and go down 2 for my other one. All right? And then we would simply repeat those. And if I look at the, come on, this is not working. If I look at the unit circle here, right? And right here I have 1, 0. I have 0, 1. I have negative 1, 0, and I have 0, negative 1, right? Well, cotangent normally starts at pi over 2, right? Cotangent normally starts at pi over 2. That's where it's 0. So if cotangent normally starts at pi over 2, and my intervals for cotangent are pi over 4. So if I go back to pi over 4, back pi over 4, that would be this angle right here. And if I draw my triangle, I can see it's 1, 1, and my cotangent's going to be 1. That's why when I go back in the negative direction pi over 4, I'm normally up 1, but instead now I'm up 2 because of my vertical stretch. Now if I go in the other direction from pi over 2, and I go pi over 4, that's going to be this angle right here. And I'm going to have negative 1, 1. So cotangent would be negative 1. So it would be over pi over 4 this way in the positive direction and down, normally 1, but 2 in this case because of the vertical stretch of 2. All right? My domain would be dot, 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 negative pi over 2 to pi over 2, dot, 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 because it starts repeating right there. And my range would be positive infinity to negative infinity. All right? So let's shift over to the second page. And let's talk about some secant graphs. So this says secant of 1/2 x plus 1. All right. What I always do is I always change it and I say, all right, this is just like, this is the reciprocal of cosine of 1/2 x plus 1. This pen is terrible. Plus 1 x plus 1. All right. So I would graph this one first. And so we know that cosine normally has a period of 2 pi, right? Well, we know that in order to find the period, in order to find the new period, we take the original period of cosine, which is 2 pi, and we divide it by whatever this number is. Well, that number is 1/2. So 2 pi divided by 1/2, you need to multiply by the reciprocal of the bottom, right? So 2 pi times 2 over 1. And that gives us 4 pi. All right, so our new period is 4 pi. Well, then our intervals are going to be 4 pi divided by 4, which is pi. All right. So now, if I start my cosine graph, normally starts at 0, 1. All right. Well, it starts at 0, 1, but now it's saying that I need to bump up the entire graph by 1. All right. So now it's here. And my new midline, instead of the x-axis, my new midline is going to be right here. All right. So now, with cosine, I know that this is the peak right here. So I need to go over an interval, which would be pi, and then down 1. All right. Over an interval and down 1. And now I'm at my bottom, right? So I drew in my dotted line. Now I go over 1, or over pi, over another pi, and up 1. Over another pi, and up 1. And then any point, after I drew in my new midline right here, any point on that cosine graph that crosses that, wherever it crosses that midline of my cosine graph, that's where I know my asymptotes are. So you can see my asymptotes are at pi and at 3 pi. And then if I drew out my midline over further, it would be at negative pi and negative 3 pi. That's where I know my asymptotes are. And then any point that has a peak or a valley, I'm just drawing my U shape within the asymptote. All right? Getting closer and closer to it. And that's how we do that one. We had no vertical stretch. We had a vertical shift up 1. We had no phase shift. And we changed our period and we changed our interval. So when we look at the domain, it would be dot, 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 negative pi to pi in union with pi to 3 pi, right? Because we have a u going up and then a u going down, and that's one complete cycle of the secant graph. All right? All right, now let's look at 2 cosecant of x. All right? Well, cosecant is just like sine, so let's say it's a reciprocal of sine, so let's try and graph 2 sine of x. Well, 2 sine of x, sine always starts, so let's just graph sine of x, 2 sine of x. Well, it starts at 0, 0, right? And normally it has an interval of pi over 2, so at pi over 2 it would go up to 1, but now we have a vertical stretch of 2. So instead of going to 1, it's going to go to 2, right? And then and then over pi over 2 more, it's going to come back to that midline, back to the 0. Then go over pi over 2 more, and normally it would go down 1, but now it's going to go down 2 because of our vertical stretch. And then this is our graph of our 2 sine of x, right? So that's 2 sine of x. Any point that crosses the midline, which, because we didn't shift it anywhere, is still the x-axis, you're going to draw your asymptote. So there's an asymptote at 0, there's an asymptote at pi, and then there's an asymptote at 2 pi. All right? And the same in the opposite direction, the negative direction. So now, wherever I have one of my peak, or one of my peaks in my sine, I would just draw a dot there and draw my V up. And then I would come down to my valley down here, and I would draw my V downward. All right? And my domain would be dot, dot, dot. You can start wherever you want, but the way I'm drawing it, I'm going from negative pi to 0 in union with 0 to pi. That would complete one cycle. Now, could I have said from 0 to pi in union with pi to 2 pi? Because that would be one cycle. That would be an up cycle and a down cycle. That would be one complete period. Yes, that would be a correct answer as well. All right. Now my range is a little different because I have everything in the negative side, so it would be negative infinity, but it comes all the way up to, and it stops at negative 2, right? Because there's nothing in this cosecant graph right here in between negative 2 and 2. So that would be negative infinity to negative 2 in union with, and we look up top here and it says, all right, we're starting our cosecant graph at 2. So it would be in union with 2, and it goes on to infinity on the upside. So it would be in union with 2 infinity. All right, so now let's take a look at our tangent graph on number 6. Y equals 2 tangent of x plus 1. All right. Well, y equals 2 tangent of x plus 1. I know that tangent normally starts at 0, 0, right? Because at 0, tangent is equal to 0. Well, I have a shift of up 1. All right. So I'm just shifting my tangent graph up 1. All right. My period doesn't change. There's no number in front of the x, so my period doesn't change. So my period for tangent is pi. All right? So my period for tangent is pi, and my interval is pi over 4, because it's just the period divided by 4. So then if I'm starting here, and I know my interval is pi over 4, I go over pi over 4, and normally I go up 1, but now because of my vertical stretch, I'm going to go up 2. And then the same on the other side, I would go back negative pi over 4. And instead of going down 1, which I normally would do, I would go down 2. And then my asymptotes are going to be at pi over 2 and negative pi over 2. Because that's where, without any shifts, that's where tangent is undefined, right? So I know my domain would be negative pi over 2 to pi over 2. That's one full period. And my range is negative infinity to infinity. All right. I had a vertical stretch of 2 on here because of this 2 right here. And I had a vertical shift up 1 because of the plus 1. I had no phase shift. And my periods stayed the same, and so did my interval. All right. So that's the graph of that.